You're welcome to my YouTube channel, Tutor Ayodele. In today's video, we'll be looking at stoichiometry. And in this video, I will make stoichiometry very easy and very easy for you guys today. Okay, so this with the chemical calculations based on the elementary particles of matters. Based on the elementary particles of matters. This diagram, this is a key diagram. You have to know before you can solve anything on stoichiometry. Although there are some other things you have to know, but this one is very, very important. It's very, very important. And we'll be looking at maybe just 1, 2, 3, 4 of these parts in this, including these 5 in this tutorial. All right. So those are those questions, 5 questions we'll be solving in this video. Now, for example, let's start looking at it. For substances of no mass, what we want to be calculating in this video is moles. Moles. Okay, for substances of no mass, just as in case when the mass is given, either the mass of the when you say substances in chemistry, it may be compound. So when the mass is given, you make use of this formula. Whenever the mass is given, just look at this question number 1 as an example. Here the mass is given to be 5.3 gram of what? Na2CO3. So the mass is given. The mass of this Na2CO3 is given to be this. So in case when the mass is given, you make use of what? This formula. So numbers of mole will be mass given over the molar mass. That is the mass given over the molar mass of this compound. The molar mass of this compound. I will also teach you how to calculate molar mass of a compound in this video. Okay? For substances of, for solutions, when dealing with solution, you know solution involves a solvent and solute to give us a solution. When you dissolve a solute in a solvent, it will give you solution. For in a case where we are dealing with solutions, numbers of mole is equal to what? Concentration in mole per dm cube times volume. And the volume, that is, we have 2 concentration. We have concentration in mole per dm cube, and the other we have concentration in gram per dm cube. So this one is concentration in mole per dm cube. So concentration in mole per dm cube times the volume. That is, our volume must be in dm cube, not cm cube, not meter cube, but it must be in dm cube. So for an ideal gas is one of the formula that is very, very essential when we are dealing with calculations in chemistry, such as stoichiometry. So our gas law. Ideal gas is very, very, very important formula. It's a key formula. So ideal gas, we have PV equals to nRT. So when you make this N subject to the formula, which is this N stands for moles, when you make it subject to the formula, we have PV over what? RT. Where our P is what? Pressure. In ATM, you may be given pressure in what is it called? mmHg, that is millimeter mercury or Pascal. You have to convert it to this. The volume must be in dm cube, where V is equal to the volume in dm cube. C is the atmospheric temperature. Atmospheric temperature is constant. That will be what? 273 Kelvin. It's constant. It's constant. So our R is a general gas constant. The number for R is also constant. Although there are 2, but although there still is 1, depend. For example, when the pressure given is in ATM and the volume is in dm cube, when the pressure given is in ATM, you can see ATM here in the units, and the volume given is in dm cube, then you make use of this. But when your pressure is in Pascal, when your pressure is in Pascal or Newton per meter square, when your pressure is in Pascal or Newton per meter square, and your volume is in meter cube, so you make use of what? This. So they are still the same. You still arrive at the same answer. And there is at the end of this video, I will teach you how they arrive at the general gas constant. This number, how they arrive at it. They don't just assume, but there is a proving for that. I will do it at the end of this video, and this one too. So that's for that aspect. So let's begin to solve our questions. We are asked to calculate the numbers of moles present in each of the following. The first one says 5.3 grams of Na2CO3. Na2CO3. Now, looking at that formula, the gram is given to be this. What we just calculate, we are calculating for the numbers of moles. So what we just calculate here is the molar mass. We need to calculate the molar mass of this compound. Okay, since you have already known this formula, since you have already written it down, if you have not written it, please put it down. Let me try to erase this place so that we can perform the calculations there. Please permit me to do that. Permit me to do that. Okay? And the unit of molar mass is a gram per dm. Sorry, gram per mole. Is in gram per mole. I don't know whether you have written it. Is in gram per mole. Yes, that is the unit of molar mass. Another way you can write this gram per mole is gram per mole. You can also see it in this form. It's still the same. Okay? So permit me to erase it. The first thing, whenever you are given a question, the first thing you have to do, especially in theory, is to write out your parameters. What are parameters? Parameters are those values given in the questions. That is what we mean by what? Parameters. If you look at this one now, it was just only one parameter that was given. The other parameters, we have to calculate it. So you write it out. Mass is a solution. Mass of Na, the mass of Na2CO3 given is what? 5.3 gram. And we said that mole, numbers of moles is equal to what? Mass over what? Over the molar mass. That part I erased. So it's just mass, I just short it, mass over the molar mass. So we have gotten the mass. Now we want to calculate molar mass of this compound. So what is the molar mass of Na? Molar mass of Na2CO3. But before you can calculate the molar mass of this compound, you have to know the mass number of each of those elements present. The mass number of each of those elements present. We have 3 elements present here: sodium, carbon, and oxygen. You have to know the mass number of each of them. What is mass number? Mass number is the sum of proton plus neutron. Okay, proton is the atomic number. It's also the same thing as the atomic number. Yes, the proton of this is the atomic number of sodium. So proton is the same thing as what? Atomic number. So let me differentiate the difference between what you're actually looking for is mass number, but let me differentiate the difference between atomic number and then the mass number. We have atomic number. We have mass number. What is atomic number? Atomic number is the number of that element, the number in the periodic table. For example, now, hydrogen is number 1. Atomic number of nitrogen is what? 1. Carbon is number 6. Atomic number of carbon is what? 6. Oxygen is number 8. If you count it, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen is the number 8. So it has atomic number of what? 8. But their mass number, now take note of this point. In the first 20 elements, I'm talking about the first 20 majorly. The first 20 elements, most of those elements, I didn't say all, but most of those elements, to get their mass number is their atomic number times 2. You understand? Atomic number times what? Times 2. For example, I said carbon is the number 6. That is, atomic number of carbon is what? 6. So what will be the mass number? 6 times 2, that will be what? 12. You understand? That is for mass number. So let's assume I'm talking about nitrogen. Nitrogen is what number? Nitrogen is number 7. What will be the mass number of nitrogen? 7 times 2. That will be what? 14. Let's assume I'm talking about calcium. Calcium is the what number? That is number 20. What will be the mass number? 20 times 2, that will be what? 40. Okay, so that is for that aspect. So what is the mass? But in some elements, as I've said, I said not all. in the first 20 elements, not all elements. Some the most elements are to get them to get what is it called? The mass number is atomic number times 2, but there are some elements that the atomic number, even though if you times it by 2, you still need to add maybe 1 or 2. For example, sodium is one of them. Sodium, is the number 11. When you multiply 11, it will be 22. But instead of the mass number to be 22, it's now give us 23. So the mass number of sodium, the mass number of sodium is not 22. It is what? 23. Now, we have sodium 23, but you will notice that it is 2 sodium that is here. That is 23 times 2, close the bracket, plus carbon is just only 1. What is the mass number of carbon? Carbon is the number 6. So the mass number will be what? 6 times 2. That will be 12. So it will be 12 plus oxygen is the number 8. The mass number will be 8 times 2. That is what? 16. So, and you know that this is 16. But if you check it very well, you notice that it is 3 oxygen that is there, because these 3 belong to this oxygen. These 2 belong to this sodium. So it's just only 1 carbon that is present. That will be 16 times 3. So here we have 46. If you multiply this and this together, 46 plus 12 plus 60 times 3. That will give you what? 48. So if you should add these 3 together, you should add it together. It will give you 46 plus 12 plus 48. It gives us 106. What's the unit of mass? What is the unit of molar mass? Because what we just did just now is molar mass. So that will be gram per mole. I said you can represent your gram per mole like this, or you can say gram per mole. It's still the same. So this is what we need. We have got our molar mass. This is what we need. So let me just erase it. But write it down in case if it is theory, all this carries mark. Please try to write it down. Okay? Now, since I've got my mass to be this, and I've got my molar mass to be this, therefore, numbers of mole is equal to what? Mass 5.3 gram over, what is our molar mass? 106. 106 gram per mole. So, if you press 5.3 divided by 106, 5.3 divided by 106, it gives us 0.05. What is the unit of mole? Is what? Mole. You will not put E here. No here has it, but this is just the unit. That is our answer for question number 1. Okay, so please try to write it down because I want to erase it because of there's no other space again. Okay. I hope you have written it. All right, let me erase it. Permit me to do that, please. Permit me to do that. Okay. The second question says, okay, there's something I did. Okay, one mole of any substance. 1 mole of any substance will give you the Avogadro's number. 1 mole of any substance will give you the molar mass. 1 mole of any substance will give you 22.4 dm cube at STP. That is, STP means standard temperature and pressure. 1 mole of any substance will give you 96,500 coulombs. That is 1 Faraday. 1 mole of any substance will give you this, and this, which is concentrations. Okay. So let's solve question number 2. Question number 2 says 4.25. We are calculating the numbers of mole present in 4.25 times 10 to the power of 21 atoms of copper. But one thing I want to take note is that this Avogadro's number, it may be atoms, it may be what? Molecule. But for here now, you are dealing with, this is copper, it will be atom, because copper is not a molecule. It's not a molecule. Copper is not a molecule because it is one, it's not a gas. It's not a gas. So it is all those gas that are molecule. So it is not a molecule, it will be what? Atoms. So that is 1 mole of copper will give you this. Because this thing is 1 mole of any substance, either atoms or molecule or any element. So 1 mole, if here is oxygen now, you know this place will change to molecule, right? Yes, if here is oxygen, this place will change to molecule. So it will now be 1 mole of oxygen is equal to what? This. You understand? But since we are dealing with copper now, it will be atom. That is 1 mole of copper, any substance, 1 mole of copper, we are dealing with copper. 1 mole of copper is equal to this. So 1 mole of copper, 1 mole of copper equals to what? Equals to 6.022 times 10 raised to the power of 23. Since we are dealing with atom now, it will be atom. Atom of what? Copper. Now, when 1 mole of copper give us this, what will this, yes, what will these atoms of copper give us? When 1 mole of copper give us these atoms of copper, what will these atoms of copper, what will be the mole it will give us? These atoms. Because this one is constant. So what will these atoms of copper give us? The mole that these atoms of copper will give us is what we want to look for. So since here is mole and here is atom, but this is atom, so let me write it under this one. I can't write it here because here is mole and I will not write these atoms under. No, let it be under atom here. So it will be 4.25 times 10 raised to the power of 21 atoms of copper. What will be the mole it will give us? We don't know the mole. So let's represent it to be what? To be X. Let's represent it to be X. So permit me to clean. Okay, let me try to manage. Let me try to manage it. So by the time you cross multiply this times this, we are still calculating moles. Let me erase this part. Let me erase this part. Let me erase this part. Since I've already solved question number 1, let me just erase it. Let me just erase it. Okay. So when you cross multiply, but before you cross multiply, let this cancel this first. So if you cross multiply, that is this times this. This times this. That will be 4.25 times 10 raised to the power of 21 times 1. You know it will still give you this. Anything you multiply by 1, it will still give you this. So it will give you 4.25 times 10 raised to the power of 21. When you multiply with this mole of copper, yeah, what I'm trying to do is that what I'm trying to do, sorry, here will be equals to is to cross multiply. Don't put sign cross multiply like this. So it means you cancel it. So don't do that in an exam. So you cross multiply. So this times this, why this we multiply this. So this times this will be mole of copper equals to X times what is there is 6.022 times 10 raised to the power of 23 what? X. So what we are actually looking for is the value of what? X. So what am I going to do? I will divide both sides by everything beside X. And these are those things beside X. I will divide both sides by this. I will divide both sides by this. So that will be 6.022 times 10 raised to the power of 23. I will also divide this one too. Sorry, here is solution. I will write it under for solution. That is solution. So divide both sides by that. That one will give you 6.022 times 10 raised to the power of 23. So when you do that, this will cancel this. So we are now left with what? X equals to. Now, if you divide this divided by what is there, that is 4.25 times 10 raised to the power of 21 divided by 6.022 times 10 raised to the power of what? 23. That will give us 4.25 times 10 raised to the power of 21 divided by 6.022 times 10 raised to the power of 23. 4.25 times 10 raised to the power of 21 divided by 6.022 times 10 raised to the power of 23. It gives us, our answer is 0.7, 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 0.7 Our answer is 0.0071 mole. And you may not see it directly like this. In calculator, your calculator may put it in standard form. So it is still the same thing as 7.1 times 10 raised to power of what? Minus 23. Sorry, minus 3 mole. So it's still the same. It's still the same because this is minus. So this point we have to move back 3 times. We have to move back 3 times. So it's still the same. Still the same. So that is our answer for question number. That is our answer for question number 2. For question number 2. I hope you have written it. Please permit me to erase it. Please, I hope you have. This video is very, very impactful. So let me know in the comments any area you want us to improve this. And if I have any challenges in any question, or if you have any challenges in stoichiometry, you can drop it on the comments. I will reply your message. If you have any questions, drop it. If you can snap it and drop it on the comments. Okay, so let's solve question number 3. Question number 3. Now, 200 cm cube of 0.25 mole per dm cube of HCl. What are we calculate HCl solution? You know that this one is talking about solution. So look at it. For solution, numbers of mole is equal to concentration in mole per dm cube. Now, if you check this, you notice that this concentration, it is given in mole per dm cube times volume in dm cube. But our volume is not given in dm cube. Our volume is given in centimeter cube. So what I will do is that I will just convert this volume to dm cube. So first thing, as I've said, you have to write out your parameters. Concentration, let me sort the concentration. I just want to summarize it like this. Concentration is equal to what? 0.025 mole per dm cube. That is the concentration of HCl given. HCl. And volume, let me summarize it to be V. Volume is equal to what? 200 cm cube. Okay, so this volume, as I've said, because here now they said the solution, so we are dealing with solution. So mole, numbers of mole is equal to what? Concentration in mole per dm cube times volume. Don't worry, I'm still coming back to this. I'm still coming back to all this, the relationship. I think I've talked about the relationship between this and this. Yes, the relationship between this and this in question number 2. So for question number 4 now is the relationship between this and this. Okay. So volume is equal to this. As I've said, we have to convert it to dm cube. If you multiply this directly, your answer will be wrong. So converting this centimeter cube to dm cube, you will divide this by what? By 1000. You will divide it by what? By 1000. So that will be 200 divided by 1000. Since I have already divided by 1000, I don't have to put this one there. I will now put dm cube. So if you press it, punch this in your calculator, this will give you 200 divided by 1000 will be 0.2 dm cube. So this is our volume. This is our volume. Now, numbers of moles, let me represent it to be N equals to concentration in mole per dm cube. What's our concentration? It's 0.025 times our volume in dm cube. You know, we have converted our volume to dm cube, so we use this, not that. We use this. That will be 0.2. So our mole N equals to, if you punch this in your calculator, that is 0.025 times 0.2. So this gives us 0.005 mole. All what we are calculating is mole, numbers of mole. Okay, that is our answer to question number 3. Okay, please, I hope you have written it. Permit me to erase it. Please. So since I've already used this formula, so permit me to erase it so that there will be more space for our calculation. Okay, I've already solved question number 3. Let me just erase it. Good. Okay. So for question number 4, We are still calculating the numbers of mole from the question. It's still numbers of mole. So what is the numbers of mole present in 16 dm cube of hydrogen gas at standard temperature and pressure? At standard temperature and pressure. Now, what was the first thing you have to note that and take note is that 1 mole is equal to 22.4 dm cube at standard temperature and pressure. Now here we are dealing with hydrogen gas, so I will now say 1 mole of hydrogen gas is equal to what? 22.4 dm cube at what? At STP. So at STP, let me just say at STP, that is standard temperature and pressure, 1 mole of hydrogen, since we are dealing with hydrogen, let me put hydrogen there. Of hydrogen gas is equal to what? 22.4 dm cube. Don't write 1 mole of hydrogen to be equal to this. So no, this is the standard one. 1 mole of this is equal to this. Then since 1 mole of this, we have got 1 mole of this to be equal to this. You are now looking for the numbers of mole that this volume will give you. That's what you are looking for. So since this is volume, dm cube, will I put it here? This is under mole. No, let me put it here. It will be under volume here. So that will be 16 dm cube will be equal to which? How many numbers of mole will it give us? We don't know it. Let's represent it to be what? X. So what you just do is to cross multiply. As I've said, don't do like this in your exam. You will write it like this, cross multiply. So when you cross multiply this, we multiply this. Why this? We multiply this. So since here is dm cube, here is also dm cube. Let me just say this cancel this. Okay. So if I say x times 22.4, that will be 22.4x equals to 16 times this. That is 16 times 1. It will still give you 16 mole of hydrogen. Mind you, we are looking for the value of x. So to get the value of x means what? You will write it in question, divide both side by 22.4. You divide both side by everything beside x. That is 22.4. You write it in an exam. If it is theory, you have to write it out. So you divide both side by 22.4. Divide both side by 22. That is 22.4. So this, we cancel this. You are now left with what? X. Now, our x is equal to, if you should punch this in your calculator, you know you cannot divide out all these, these are variables. You can't say variable divided by this, so it will be this number divided by this. 16 divided by 22.4, 16 divided by 22.4, what does that give us? It gives us 0.714 moles of what? Mole of hydrogen. That is, when this 1 mole give us this volume at standard, that one is standard, don't change it. Then this volume will now give us what? This mole. This is the mole it will give us. Sorry, hydrogen. Here is there. Here is there. So, have you written that one? Permit me to erase it again. Permit me. As time goes on, we look for a bigger whiteboard. Permit me. Okay, thank you. Now, we have come to these questions. Number 5. Now, we are given volume. First thing you have to do, as I've said, whenever you are solving a question, write out your parameters. Your parameters are those values given. We have, what was given there? Volume. Volume equals to what? 250 cm cube. Okay. We're also given exactly a pressure. Pressure. Let me represent it to be P, permit me. Pressure is equal to 720 mmHg. And then at what? 37 degrees. That's our temperature. Temperature is equal to 37 degrees Celsius. Okay? What are we calculating? Numbers, that is numbers of mole, is unknown. We don't know it yet. Now you will look for a formula. that relate volume, pressure, temperature, and numbers of mole. You will notice that it is what? This ID gas. This is pressure, this is volume, this is numbers of mole, and this temperature. This is constant. It has a constant number. All right. But before you can just begin to substitute, there are some rules that guide it. That your pressure must be in ATM. If you want to use, for example, now, if you want to use this, your pressure must be in ATM. You can see ATM here. Your volume must be in DMQ. You can see DMQ here. And you know our temperature, it must be in Kelvin. It must be in Kelvin. Our temperature must be in Kelvin. So that is if you want to use this. So therefore, let's look at our volume. We said our volume must be in DMQ. Is our volume in DMQ? No. So we have to convert it first to DMQ. That will give us, to convert to DMQ, you divide by 1000. Divided by 1000 dm cube. And if you punch it to your calculator, it will give you 0.25 dm cube. That's for that. Now our pressure. Is our pressure given? We said our pressure must be in ATM. Is our pressure given in ATM? Don't just substitute direct, you will get wrong answers. You have to convert the pressure to be in ATM. Is our pressure given in ATM? No, it's in mmHg, that is millimeter mercury. So to convert from to convert to ATM, you will divide by 760. So that will be equals to 720 divided by 760. Since you have already divided by 760 to be ATM. So if you punch that in your calculator, 720 divided by 760, it give us equals to 0.9 5 ATM. So that is our temperature. Sorry, that is our pressure. That is our pressure. So for the temperature, you have to convert it to Kelvin. To convert from degree to Kelvin, is just add. You just say so it's equals to 37. You just add 273 plus 273. That will give us. If you add this and this together, it will give you 310 Kelvin. 310 Kelvin. So then, since I've already gotten that, then we can then make use of this value to be our R. Therefore, our R is equal to what? 0.0821 ATM. You see, one thing I will show you, this unit, how they arrive at this unit, I will show you at the end of this video. They don't just arrive, you don't need to cram this unit. I will show it for you, easy way you can get it. dm cube. You can another way you can also rewrite it. You can say it's still the same thing as mole Kelvin. It's still the same. And if you don't want to write it like this, you can also write it like this again. Still the same thing as this, but this one will not be raised to power minus 1. Okay, will also be raised to power minus 1. So then we can substitute our parameters into our formula. You know, this is the formula. You notice that this is the formula that relates everything together. So numbers of mole equals to what? PV over what? RT. So what's our P? Our pressure. Our pressure is given to the what? Our pressure is this. We have changed it to this. That is 0.95 times, what is our volume? We have converted it to this. 0.25 all over. What's our R? Our R is this, which is this. That is 0.0821 times, what's our temperature? Our temperature is this, 310. So, 310. So if you should punch this in your calculator, if you punch it in your calculator, 0.95 times 0.25 divided by 0.0821 times 310. That gives us 0.0093 mole. So that is our final answer. It's still the same thing as this. 9.3 times 10 raised to the power of minus 23 mole. It's still the same. It's just that here I converted it to what? Standard form. Converted it to standard form. So that is our final answer to that. Okay. I said I will prove how they arrive at this and this, but because I don't want to take much time in this video, watch out my other video. There's a separate video for this, separate videos, so you can kindly watch it out. So please, if you have any questions, any challenges in this course, please drop it on the comments, or any questions. I will reply your message, and I will make sure that the video will be available for you guys. So, and do well to share the videos to your friends. Tell your friends about this. Like, comment, share. Thank you.